Picture this: October 1969 at Lyons Drag Strip. A primer-spotted Camaro, driven by a nobody transmission mechanic, lines up against a $12,000 Hemi Cuda that's never lost. The Camaro launches like it's been shot from a cannon, runs 10.6 at 131 miles per hour, and leaves the Cuda sitting there like someone hit pause. Here's the thing: the engine was completely stock. The modification that made it unbeatable was hidden inside the brake lines. And according to every engineer in Detroit, it should have been absolutely impossible. The crisis of 1969. The year is 1969, and American drag racing is in the middle of an arms race. Funny cars are making 1,000 horsepower. Pro stocks are running 9s. Even street classes are getting stupid fast. The problem is that all this power is basically useless if you can't get it to the ground. Traction technology in '69 consisted of slicks, some welded rear ends, and prayer. Launch technique was everything. Too much throttle off the line and you'd go up in smoke. Too little and you'd get walked by cars with half your horsepower. The sweet spot was maybe 1/10 of a second wide, and finding it required the reflexes of a fighter pilot and the mechanical sympathy of a watchmaker. The real issue was weight transfer. When you punch a high-powered car from a dead stop, all the weight shifts to the rear axle. This is good for traction, obviously. More weight on the drive wheels means more grip. But the transition is violent. The front end lifts, the rear suspension compresses, the whole chassis starts oscillating like a tuning fork. If you could control this weight transfer, smooth it out, make it progressive instead of sudden, you could launch harder without breaking traction. Every mechanic and driver in America knew this. The question was how. Suspension tuning could only do so much. Stiffer springs in the front to slow the weight transfer meant the car sat nose high and looked ridiculous. Softer springs in the rear to cushion the compression meant the car would bottom out and lose traction when the suspension rebounded. Drag racing shocks existed, but they were expensive and usually just delayed the inevitable rather than solving the problem. Some guys tried adding weight to the front end. This helped a little but made the car slower overall because, well, you're adding weight. The smart money was going into clutch and transmission tricks. Multi-disc clutches that could slip just the right amount. Automatic transmissions with custom valve bodies that could modulate line pressure during the launch. These worked, sort of. They also cost a fortune and required constant rebuilding. The clutches would glaze. The transmissions would grenade. It was an expensive way to go, maybe 2/10 quicker. What racers really needed was a way to mechanically limit how fast the weight could transfer without adding complexity or cost. Something simple, something elegant. Something that worked with the car's existing systems instead of fighting them. In October of '69, a mechanic in Gardena, California, figured it out using nothing but brake lines, a handful of restrictors, and an understanding of hydraulics that would have made the engineers at Chevrolet weep with envy. Enter Jerry McNamara. Jerry McNamara was nobody's idea of an engineering genius. He was a 32-year-old transmission specialist who ran a small shop in Gardena, fixing automatics for local hot rodders. He'd never worked for Detroit, never designed anything for a major manufacturer. His formal education consisted of a high school diploma and whatever he'd learned taking apart power glides in his parents' garage. What McNamara had was an obsessive attention to detail and a habit of noticing things other people ignored. McNamara had been drag racing since '57 when he was still a teenager running a flathead Ford at San Fernando. He'd built his first serious race car in '63, a 4-speed Chevy 2 with a 283 that ran consistent 13s. Nothing spectacular, but reliable. He noticed early on that his launches were inconsistent. Same car, same track, same weather, but his 60-foot times would vary by as much as 3/10. Some runs the car would hook and drive, other runs it would spin or bog. He couldn't figure out why. Most racers would have blamed driver error or track conditions and moved on. McNamara started taking notes. He logged every run, tire pressure, temperature, throttle position, everything he could measure. After 2 seasons of data collection, he noticed something strange. His best 60-foot times always came on runs where the brake pedal felt slightly soft at the starting line. Not dangerously soft, just a little mushier than normal. His worst times came when the pedal felt firm and responsive. This made no sense. Why would soft brakes correlate with good launches? McNamara started experimenting. He'd bleed the brakes before some runs, making them deliberately soft. His times improved. He'd flush the system and get fresh fluid, making them firm again. His times got worse. There was clearly something going on with the hydraulic system that affected how the car launched. But what? Here's where McNamara's transmission background became crucial. He understood hydraulics. He knew that fluid under pressure behaves in specific, predictable ways. When you press a brake pedal, you're creating pressure in a closed hydraulic system. That pressure moves through steel lines to the wheel cylinders where it creates braking force. The system is designed to be responsive, meaning the pressure builds and releases quickly. But what if you didn't want it to be responsive? What if you wanted it to be slow and progressive? McNamara started thinking about the front brakes specifically. When a car launches hard, the front end lifts. As it lifts, the brake pads pull away from the rotors. This releases the hydraulic pressure in the front brake system. The fluid flows back through the lines to the master cylinder. This happens almost instantaneously in a normal brake system. But McNamara wondered, what if you restricted that flow? What if you slowed down how fast the pressure could release from the front brakes? The theory was simple but brilliant. If the front brake pressure couldn't release quickly, it would create a temporary resistance to the front end lifting. Not enough to keep the wheels on the ground, obviously. Just enough to slow down the rate of weight transfer. Instead of all the weight slamming to the rear in a fraction of a second, it would flow progressively over maybe half a second. This would give the rear suspension time to compress gradually, maintaining traction without the violent oscillation that killed grip. McNamara built his first prototype in his shop over a weekend in September of '69. He took a '68 Camaro SS that belonged to his cousin. The car was basically stock. 396 cubic inch big block, 4-speed, decent but not amazing. He installed brass restrictors in the front brake lines between the master cylinder and the wheel cylinders. The restrictors were tiny, maybe 30/1000ths of an inch orifice, barely visible to the naked eye. They allowed fluid to flow into the front brakes, normally when you press the pedal. But when the pressure released, the fluid had to flow back through those tiny orifices, which took time. The first test was a disaster. The restrictor was too small. The front brakes wouldn't release at all, and the car did a wheel stand that ended with the front bumper in the dirt and McNamara's cousin screaming about his paint job. McNamara adjusted. Bigger orifice, 45/1000ths. Too big. No effect at all. He spent 3 weeks finding the sweet spot, 37/1000ths, with a specific taper angle that created progressive restriction based on flow rate. It was watchmaker-level precision in a brake line. The problem, everyone ignored. To understand why everyone said McNamara's brake line trick was impossible, you need to understand the problem with hydraulic brakes. The whole point of a hydraulic brake system is instant response. You press the pedal and the car stops now, not in a couple seconds. This is achieved by having completely unrestricted fluid flow through large diameter lines and ports. Any restriction in the system is considered a defect. It causes delayed braking response, which can literally kill you. McNamara was intentionally creating a restriction in the brake system. Every hydraulics engineer who heard about this said the same thing. You're going to get someone killed. The front brakes won't work when you need them. The car will crash. It's insane. And they had a point. Brake safety is not something you mess with. The DOT has entire departments dedicated to brake regulations. Adding restrictors to brake lines violates about 17 different safety standards. But here's what the engineers missed. McNamara wasn't restricting brake application, only brake release. When you press the pedal, fluid flowed through the restrictor in one direction, almost unrestricted, because the taper was designed to create minimal resistance to incoming flow. The restriction only happened when the fluid tried to flow back. This meant the brakes worked normally when you needed them to stop the car. The restriction only activated when the front end lifted during launch and the brake pads separated from the rotors. The second objection was that it wouldn't work for drag racing anyway. The amount of restriction needed to meaningfully slow down weight transfer would be so great that the front brakes would stay partially engaged during the run. This would create drag, slow the car down, and potentially lock up the front wheels if you tried to brake at the top end. McNamara solved this with the tapered orifice design. At low flow rates, the restriction was significant. At high flow rates during hard braking, the turbulence and pressure differential actually increased flow efficiency. It was self-regulating. The third objection was durability. Restrictions in hydraulic systems create turbulence and heat. The fluid would break down. The restrictors would clog with contaminated fluid particles. The system would fail randomly and catastrophically. McNamara addressed this by positioning the restrictors in the coolest part of the brake line and using a sintered bronze filter element before the restriction point. The filter caught particles. The bronze dissipated heat. Simple solutions to predictable problems. What made McNamara's system truly brilliant was that it worked with the car's natural dynamics instead of fighting them. During launch, as the front end started to lift, the front brake pressure would slowly release over maybe 0.4 of a second. This created a progressive damping effect on the weight transfer. The suspension could respond gradually to the load instead of all at once. The car would squat smoothly instead of violently. The tires could bite and drive instead of spinning or hopping. The system was also adjustable. Different restrictors could be swapped in minutes to tune the launch characteristics for different track conditions, different tire compounds, different power levels. A slightly smaller restrictor would make the weight transfer slower and smoother for a high-powered car on a sketchy track. A larger restrictor would allow more aggressive launches for a lower-powered car on a prep track. It was infinitely tunable, with parts that cost maybe $3. But the real genius was in the integration. McNamara didn't add a separate system or a new component that could fail. He modified an existing system in a way that enhanced its function without compromising its primary purpose. The brakes still worked. The car was still safe to drive on the street. You could literally drive to the track, install the restrictors, make your passes, remove the restrictors, and drive home. No one would ever know the car had been modified unless they looked very closely at the brake lines. The impossible solution. The installation was hilariously simple. Disconnect the front brake lines at the master cylinder, install the restrictor fittings, reconnect the lines, bleed the system. Total time with basic hand tools, maybe 45 minutes. McNamara's first installations included detailed instructions written on index cards, 37 thousandths for big blocks, 42 thousandths for small blocks. If the front end lifts too fast, go smaller. If the brakes drag, go bigger. Test at low speeds first, you idiot. The cost was equally absurd. McNamara made the restrictors himself on a lathe in his shop. Material cost was maybe 50 cents per restrictor. The brass fittings were standard AN hardware, available at any speed shop for a couple bucks. Total cost to transform a car's launch capability, less than $5. Compare this to a custom clutch setup at $500 or a transmission valve body at $700. McNamara had found a $5 solution to a $1,000 problem. The technical specs were precise but not complicated. Restrictors machined from brass rod stock with 3/8 24 inverted flare thread. The interior bore tapered from 3/8 inch down to 37 thousandths at the restriction point, then opened back up. The taper angle was 12 degrees on the inlet side, 20 degrees on the outlet. This asymmetric design was genius. Fluid could enter easily but had to squeeze through on the way out. McNamara added a fine mesh bronze screen on the inlet side, maybe 100 mesh, caught particles before they could clog the restriction, added 5 cents to the cost and prevented 99% of failures. The kind of detail that separated clever from reliable. The technical deep dive. The physics behind McNamara's system are actually straightforward once you understand hydraulic damping. When fluid flows through a restriction, it creates back pressure proportional to flow rate and viscosity. In a brake system, when the front end lifts during launch, the brake pads separate from the rotors. Normally, the pressure drop would be instantly equalized by fluid flowing back through unrestricted lines. But with McNamara's restrictors in place, the fluid can't flow back quickly. The restriction maintains pressure in the front brake system even as the pads separate from the rotors. This residual pressure doesn't engage the brakes, but it creates a hydraulic damping force that resists the front end lifting. The faster the front end tries to lift, the more resistance the restriction creates. It's a passive, self-regulating damping system built from $5 brake parts. McNamara figured out through testing that brake fluid at operating temperature flowing through a 37 thousandth restrictor creates about 0.4 seconds of damping time, long enough to smooth out the launch, but short enough that it doesn't affect vehicle dynamics once the car is moving. The system also benefits from what engineers call hysteresis. During brake application, high flow rate creates turbulent flow that actually reduces the effective restriction. The fluid molecules bounce around, creating a self-clearing effect that maintains good brake response. During release, lower flow rate creates laminar flow that maximizes the restriction effect. The system is effectively two different restrictors in one, depending on flow direction. Temperature effects were minimal. Cold fluid at 60 degrees flowed about 15% slower than hot fluid at 200 degrees. This translated to maybe a tenth of a second difference in damping time, which was within the adjustability range of swapping restrictor sizes. The restrictors added about 0.1 seconds to initial brake application time from a dead stop. From a safety standpoint, this was acceptable because 0.1 seconds is imperceptible to human response time. At high speeds, the effect disappeared completely. When you're braking from 100 miles per hour, you're generating so much hydraulic pressure that the restriction becomes meaningless. Emergency braking capability was unchanged. Durability exceeded expectations. McNamara had restrictors in service for over 5 years that showed no measurable wear. The limiting factor was usually the rest of the brake system failing before the restrictors did. The first test. The first real test happened on a Thursday night at Lyons in early October of '69. McNamara had convinced his cousin to let him take the Camaro for test and tune. The car had the restrictors installed, but was otherwise completely stock. 396 with maybe 350 horsepower, highway gears, street tires that McNamara had swapped for a used set of M and H Racemasters. Nothing special. The car had run mid-13s on previous outings with inconsistent 60-foot times, ranging from 2.1 to 2.5 seconds. McNamara's goal for the night was simple: run 10 passes and see if the restrictors made the car more consistent. He wasn't expecting miracles, he just wanted predictable launches. The first pass was cautious. McNamara staged shallow, brought the revs up to maybe 3,000, and released the clutch smoothly. The car squatted. That was the first thing he noticed. Instead of the violent weight transfer that would normally slam the rear suspension to the bump stops, the car lowered itself progressively onto the rear tires. The front end lifted, but slowly, gracefully, almost like it was on a hydraulic lift. The 60-foot time was 1.8 to 9. The previous best for this car was 2.1. McNamara had just picked up over 2/10 on a conservative launch. The car ran a 12.9 at 109 miles per hour, 3/10 quicker than it had ever been, and he'd barely been aggressive with the launch. Second pass, he brought the revs up to 4,000. Same smooth squat, 1.8 to 5, 60 foot, 12.8 at 111. The car was getting quicker and he was just learning how to use the system. By the fifth pass, McNamara had figured out the technique. Stage deep. Bring the revs up to 4,500. Sidestep the clutch like you're trying to brake the transmission. The car would squat hard but smoothly. The tires would bite instantly because the weight transfer was progressive enough that they could grip instead of spin. The front end would lift maybe 6 inches off the ground and just hang there for the first 60 feet while the car accelerated like it was on rails. Pass number 8 was the one that made McNamara realize he'd found something special. 1.8 to 160 foot, 12.6 to 3 at 114 miles per hour. This was with a completely stock engine. No headers, no cam, no porting, nothing. Just better traction from controlled weight transfer. McNamara started doing math in his head. If he could pick up 4/10 just from launching better, what could the system do on a car with actual power? The other racers started noticing. By pass 9, there was a small crowd watching this nobody in a primer-spotted Camaro running times that should have required serious money. After pass 10, which ran a 12.5 to 8, the question started. What's in the motor? Stock. What gears you running? 3.3 to 1 highway gears. What clutch? Stock clutch. The looks of disbelief were priceless. Someone finally asked about the launch. How are you getting it to squat like that without wheel hop? McNamara smiled and said something about suspension tuning. He wasn't ready to share the secret yet. He needed more data. He needed to know if the system worked on other cars. He needed to understand the limitations. Most importantly, he needed to beat some people who deserved beating before word got out, and everyone copied his trick. Domination begins. The following weekend, McNamara went to the NHRA divisional race at Irwindale. He'd borrowed a friend's '69 Chevelle SS with a 454 and a 4-speed. The car made about 420 horsepower and had been running low 12s with terrible consistency. Some runs it would hook and run 11.9s. Other runs it would spin and run 13 flats. The owner was about to sell it out of frustration. McNamara installed his restrictors, did some test passes to dial it in, and then entered Superstock Automatic. Yes, the car had a 4-speed. No, that didn't matter, because McNamara entered under a fake name and nobody checked too carefully in '69. The class was supposed to be for cars, running 11.5 to 12 flat. McNamara's first qualifying pass was an 11.2 to 8. His second was an 11.3 to 1. Perfectly consistent. He qualified third. First round, he faced a 400-horse GTO with a seasoned driver who'd been racing for 15 years. McNamara cut a perfect light, launched so hard the front wheels came up a foot, and ran an 11.3 to 2. The GTO ran an 11.7 after spinning off the line. Second round, another GTO, this one with more power. McNamara's car launched like it was shot from a cannon, 11.2 to 9. The GTO ran 11.6 after wheel hop destroyed its 60-foot time. By the semifinals, people were starting to ask questions. How is this car so consistent? What's the secret? McNamara kept his mouth shut and his hood closed. Finals were against a Camaro with a professionally built motor that had won this class 3 times in the past year. The driver was sponsored and everything. McNamara staged, brought the revs up, dumped the clutch. The Chevelle squatted, hooked, and drove like it was welded to the track. 11.2 to 7 at 122 miles per hour. Personal best. The Camaro red lit trying to compensate for McNamara's aggressive launches. McNamara won on a foul. That night, McNamara revealed his trick to exactly 3 people. 2 fellow mechanics he trusted, and 1 racer who'd been honest about his struggles with consistency. He showed them the restrictors, explained the hydraulics, and helped them install the systems on their cars. Within 2 weeks, all 3 were running personal bests and winning races they had no business winning. The word started spreading through the Southern California drag racing community. Jerry McNamara has a trick that makes cars hook like fuel dragsters. It's something with the brakes. Nobody knows exactly what, but it works. By November of '69, McNamara was installing brake line restrictors on a dozen cars a week out of his shop. He charged $50 per installation, which was basically nothing for the performance gain, and he couldn't keep up with demand. The results spoke for themselves. Cars that had been running mid-13s were suddenly running high 12s. Low 12 cars were dipping into the 11s. Guys who'd been struggling with consistency were suddenly running within 1/100th of a second on every pass. NHRA officials started noticing that an unusual number of cars from the Gardena area were suddenly setting records and winning races. In December, McNamara took the modified Camaro to Lyons one last time before his cousin sold it. He'd refined the restrictor design, figured out the optimal orifice size for the car's weight and power, and practiced his launch technique until it was muscle memory. The car now had headers and a mild cam, bringing power up to maybe 400 horses. Nothing crazy. The track record for Superstock Eliminator was 11.1 to 5, set by a Yenko Camaro with a full race motor and about 10 grand in engine work. McNamara's first pass was an 11.4. The second was an 11.2 to 8. The third pass, with everything perfect, tire pressure dialed in, weather conditions ideal, McNamara staged deep, brought the revs up to 5,000, and launched like he was trying to put the car into orbit. The 60-foot time was 1.7 to 3. Incredible for a street car. The car ran an 11.0 to 8 at 126 miles per hour. New track record. The tech inspectors swarmed the car, pulled the intake, checked the heads, measured the compression. Everything was legal. They had no idea the secret was in the brake lines. Detroit's response. Detroit's response to McNamara's brake line trick was predictably defensive. When word reached GM and Ford in early 1970, the initial reaction was dismissal. A mechanic in California had figured out something their PhDs missed? Impossible. It must be some other modification he wasn't disclosing. Nobody can improve launch performance with brake lines. That's absurd. Then someone at Chevrolet actually tested it. They took a stock Camaro Z28, installed McNamara's restrictors using the exact specifications now circulating in hot rod magazines, and ran it at GM's proving grounds. The results were undeniable. 60-foot times improved by 0.2. Consistency improved dramatically. The engineer who ran the test wrote, "Simple, elegant, effective, and we should have thought of it first." GM's response was to ignore the whole thing publicly while quietly incorporating progressive hydraulic damping concepts into their future designs. Ford did the same. Chrysler sent someone to McNamara's shop with a briefcase full of cash, trying to buy the rights. McNamara told them where they could put their briefcase. He was making good money installing the systems and had no interest in selling out. NHRA had a different problem. McNamara's system didn't violate any existing rules. The rulebook said nothing about restricting brake line flow. It wasn't an engine modification. It wasn't a suspension modification. The rulebook writers literally didn't have a category for what McNamara had invented. NHRA tried to ban it 3 times. First attempt in March of '70 required all brake systems to maintain factory specifications. Racers pointed out this would outlaw braided lines, aftermarket master cylinders, and 50 other common modifications. Withdrawn. Second attempt in July tried banning any modification using brakes for weight transfer control. Unenforceable. Dropped. The third attempt in October was sneaky. All restrictors must be painted bright orange and clearly labeled. This actually passed. McNamara's response was brilliant. He made the restrictors from clear plastic, painted them bright orange as required, with labels reading, "Flow Control Device, legal per NHRA rules." The tech inspectors hated him, but couldn't do anything about it. By 1972, 3,000 cars in America were running McNamara's brake line restrictors. The legacy. The legacy of McNamara's brake line trick extends far beyond drag racing. The principle of using hydraulic restrictions to control dynamic load transfer influenced suspension design for decades. Modern cars with adaptive damping systems are essentially doing electronically what McNamara did mechanically. Progressive rate springs, which became standard on performance cars in the '80s, work on the same principle of slowing down weight transfer to improve traction. McNamara himself never got rich from his invention. He refused to patent it because he believed good ideas should be shared freely among racers. He continued running his transmission shop in Gardena until he retired in 1995. He died in 2003 at 66, largely forgotten by the automotive world he'd helped revolutionize. His obituary in the local paper made no mention of the brake line trick that changed drag racing, but his influence lives on. Every time a modern launch control system modulates brake pressure to control weight transfer, it's using McNamara's principle. Every time an electronic stability system uses individual wheel braking to manage chassis dynamics, it's building on the foundation McNamara laid. The idea that hydraulic brake systems could do more than just stop the car, that they could actively manage vehicle dynamics, started in a Gardena transmission shop with a guy making restrictors on a lathe. The broader lesson here is about innovation and corporate blindness. McNamara solved a problem that thousands of Detroit engineers had looked at and decided was unsolvable within reasonable cost constraints. He did it with parts that cost less than $5 and an understanding of hydraulics that any decent mechanic should have had. The major manufacturers missed it because they were looking for complex solutions to complex problems. Sometimes the best answer is simple, obvious in retrospect, and right in front of you the whole time. Looking back at McNamara's brake line trick from 50-plus years later, what's most remarkable is how perfectly it captured the spirit of '60s hot rodding. No computers, no exotic materials, no million-dollar R&D budgets, just a guy who understood hydraulics, paid attention to details nobody else cared about, and had the guts to try something everyone said was impossible. The '69 Camaro that started it all still exists, by the way. It's owned by a collector in Arizona who has no idea about its historical significance. The brake line restrictors are long gone, replaced during a restoration in the '80s. The car sits in a climate-controlled garage, completely stock, worth maybe $40,000. If someone knew its real story, knew that this was the car that proved Jerry McNamara's impossible trick actually worked, it would be priceless. That's the thing about forgotten innovation. Sometimes, the most important breakthroughs happen quietly, in small shops, by people who never get credit. McNamara didn't invent the brake line. He didn't invent hydraulic restrictions. He just put them together in a way nobody had thought of before and changed drag racing forever. Every modern launch control system owes something to a transmission mechanic in Gardena who noticed his brakes felt soft on his best runs and had the curiosity to figure out why. So, next time you see a modern car launch perfectly with computer-controlled everything, Remember that the principle started with brass restrictors in brake lines, installed by a guy who charged $50 and wrote the instructions on index cards. Sometimes the best engineering doesn't come from laboratories. It comes from mechanics who actually pay attention to what the car is telling them.